Hello everyone, welcome back. I'm GOD and today I'm going to be reacting to my most viewed TikTok to date, and it's about how I work with strong acids.
GOD rocks.
So these TikToks are filmed in two parts. First, let's go with part one.
Preparing an acid bath.
Okay, so in this video, I'm creating a 5% nitric acid solution, starting from an acid concentrate of about 70%. Always gotta lay down the bench protector. Don't wanna pour acid onto the bench.
Pour.
Okay, so the reason why I'm not pouring acid straight from the container into my dilution beaker is because in chemistry, we follow the rule that you absolutely never take from the stock bottle or from the stock solution bottle. You always decant your substance into something else first, and then you use from that bottle. Okay, and the reason why I can't just pour the acid into the plastic bottle and I have to use a funnel is because when working with dangerous substances like acids or caustic solutions, you want to minimize splash as much as possible. So that means in the case of acid, you really always need to use a funnel. Good safety procedure.
Part 2.
Okay, for part 2,
Fill container with 10 liters of deionized water. Add the concentrated acid.
so as I'm mixing the acid into the water, you can see the vapors coming off of the solution. And if you look closely, you can actually see where the acid is diluting and mixing into the bucket of water.
Where the acid and water are mixing, we always add acid to water and never water to acid.
Yes, very true. Chemists will always follow the rule of acid to water and never water to acid.
Cover acid bath to contain any vapors.
So in the video, I'm diluting about 400 ml of concentrated acid into a container holding about 500 ml of deionized water. What is deionized water? Well, in short, deionized water is just pure water. Unlike tap water or any natural water you will find, DI water is especially filtered to contain no ions, which is important because when we create solutions in the lab, we want to be absolutely sure that the only elements present in that solution are the ones that we put in there on purpose. And depending on the work being done, even the smallest amount of contamination can cause problems later on down the line. So the main focus of this video was to share the fact that when diluting acids, chemists always follow the rule of acid to water and never water to acid. It may seem trivial, but not following this rule can have some pretty devastating consequences, especially when diluting strong acids. Okay, so why? Why is the order of dilution critical when diluting acids?
Let's use HCl as an example. A strong acid dissociates completely in solution, meaning the compound is split into its ionic components. This is due to a process called hydration. However, the ionic components H+ and Cl- don't float around freely in the surrounding water molecules. Since they are ions, they are actually hydrated. As the acid is diluted, there becomes more water molecules available to hydrate these ions. And this hydration is an exothermic process, meaning it releases heat.
So now for the impressive part. All substances have this property called specific heat capacity, which is the amount of energy required to raise the temperature of 1 gram of substance by 1 degree Celsius. And water, which is the coolest substance to ever exist, I mean, really, it's just perfect, has a very, very high heat capacity, meaning water can absorb a large amount of heat with only a small change in temperature. This property of water is why the order of acid dissolution matters so much. When a small amount of acid is added to a large container of water, there is a lot of water available to absorb the heat that is produced from the hydration. However, in the reverse, you can get an extremely acidic solution that heats up very, very quickly. And that can result in a pretty dangerous situation. And honestly, it's even scary. This rule of acid to water and never water to acid can easily be mixed up, so every chemist really has their own way of remembering this. When I first learned to dilute acids, I was also struggling to remember this rule, and to be honest, to this day, the main way that I remember this rule is through a scary story that my grade 12 science teacher, Miss Ropret, told our class. Hi, Miss Ropret, if you're watching. She told the class a story about an accident that happened during one of her undergraduate lab sessions, where a student had a plastic beaker full of strong acid and went to dilute that acid by pipetting in some water. And as I explained before, that acid heated up so quickly, so fast, that the bottom of the plastic beaker began to stretch and balloon. And eventually, the plastic got so hot and so stretched that the bottom of the beaker broke and it splashed concentrated acid everywhere, resulting in a major accident. And when I tell you that story scared me, it scared me into always remembering this rule, so I just had to come up with my own hack to remember it. And I figured anything to do with food, I will obviously remember that because I love to eat. So I labeled this rule in my chemistry notebook as A and W, just like the fast food place, because I know I'll never drive up to a W and A. So A and W, acid to water, was always something that I could remember. And of course, all of you guys should follow the rule HTSB. Hit that subscribe button. And if you learned something from this video, please, please, please tell it to the algorithm by liking this video. And if you want to see more just like this, hit that notification bell.